Now we have a really interesting question here. So, if you actually go by the go by the standard textbooks, you'll find that most of this question is most of the books mention this question in the chapter work energy part. But at the same time, you can also include this in the chapter friction, the chapter containing friction, which is a loss of motion. So what I'm going to do here is we will solve this question using two methods. One, applying the work energy theorem, okay, which we'll do as a separate one. Second, we'll uh, solve this question using laws of motion and equations of motion. Okay, so this is going to be a bit, a bit elaborate because you need to understand the concept really well in both the cases. Only then you'll be able to understand the difference in application of work energy theorem, which also in future you have conservation of mechanical energy as well. So you should be able to read a question and then the intuition should come into your mind: which approach should I use? Should I go for loss of motion? Should I go for work energy power? Should I go for conservation of mechanical energy or the work energy theorem? So that differentiation should come into your mind. That's the whole purpose of solving this same question in multiple methods. Having said that, let us first move on to the solving of this question using loss of motion. So, for that, what I've done is we first do the process of visualization. A small block starts slipping from a point B on an inclined plane AB, which is making an angle. So, a point B, inclined plane AB, there's a horizontal. Section CA is rough, CA is rough, and BC is smooth. Given to us that BC is equal to 2AC. So let us assume that AC is equal to X, AC is equal to X. So therefore, what is BC? If you want to make more sense, the diagram this should ideally be like this, right? Yeah, somewhere over here. Makes sense. Okay. So we have BC is equal to 2X. All right. And the coefficient of friction is given by mu is equal to K tan theta. We've been asked to find the value of K. So what we'll do is we'll first try to understand for the motion along BC, what are the various forces acting on this body? Since there is friction absent in this, we can say that the only two forces acting are: number one, the force of gravity, which is mg acting downwards, and then number two, which is normal reaction, which is perpendicular to the inclined plane. And what normal reaction is? Normal reaction on the block due to the surface, inclined surface, right? So these are the two forces acting here. And if these are the two forces acting here, how can we draw the free body diagram? We can draw the free body diagram by considering this complete block as one small mass and which has two forces acting on it: normal reaction, which is perpendicular to the plane, and then we have weight, which is acting downwards towards the center of the earth. Now we know that weight being inclined can be resolved into two components. Which are they? Weight can be inclined, weight can be resolved into one component which is horizontal to the plane. So we see this is BC, right? BC is the plane. So we'll have one component which is horizontal to the plane. So this is horizontal to the plane, right? And we can resolve it into another component which is perpendicular to the plane. And this horizontal component we will name this as mgx, and the vertical component we'll name it as mgy, right? So we have mgx and mgy. Now, if you consider the weight and the vectors, the component vectors as a triangle, we have theta, mg, mgy, and mgx. From this triangle, what is sine theta? Sine theta would be opposite, which is mgx, by hypotenuse. Okay, is there a mistake here? Let me just check the angles one more time. Yeah, so if you make this more correct, this angle is 90 degree. My bad. Yeah, okay. So now things are correct. This angle here is 90 degree. Okay, all right. So yes, so we have mgx is equal to mg into sine theta, mg and sine theta. Similarly, if we take cos theta of this angle, we have mgy is equal to mg cos theta. So the vertical component is mgy, which can be replaced by mg cos theta, and the horizontal component is mgx, which can be replaced by mg sine theta. Now, if you draw the free body diagram of the block, we can replace mgx and mgy by mg sine theta and mg cos theta. Okay. Now, which essentially means that we need not consider this weight component. It can be replaced with these two components, right? Okay. After that, let us consider for the vertical motion. Since there is a block here, this block is not moving vertically. It is not moving upwards, nor it is moving downwards. Its motion is restricted only along the horizontal plane, which means that there is no vertical motion. And since there is no vertical motion, sigma Fy is going to be equal to 0, which further implies that forces acting upwards should be equal to forces acting downwards. The only force acting upwards is normal reaction. The only force acting downwards is mgy, which is mg cos theta. Therefore, we can write that normal reaction is equal to mg cos theta. If you understand this portion, then we can say that as we discussed mgy, we can now discuss mgx. But like I said earlier, this block here is restricted to move along the x-axis, and it has some motion along the x-axis. It has some displacement, it has some acceleration. Therefore, we can say that sigma fx would be equal to m into ax. Now, what does sigma fx means? Sigma fx means sum of all the forces acting in the x direction. What are the forces acting in the x direction? The only force that is acting along the x direction here is mgx, which is equal to mg sine theta. Now, the overall direction of motion is acting downwards because the block here is sliding downwards, which means mg sine theta and displacement are in the same direction. Therefore, for mg sine theta, you choose a sign positive. So, if it is positive, mg sine theta is equal to max. So, m and m will cancel. What we get is ax is equal to g sine theta. Okay. Now, let us see for the motion along BC. The net direction of motion is downwards. The distance traveled by this block here is from B to C, which we have assumed to be 2x. And we can say that this motion along BC can be summarized as motion along 2x with acceleration equal to g sine theta. One more time, motion along BC can be summarized as motion along BC with distance 2x with acceleration g sine theta. Now, if that is the case, if you consider the initial and the final position where initially the body is at P and finally the body is at C, we can say that this initial condition velocity is Vb and final condition the velocity is V represents final velocity is velocity at C, and acceleration is g sine theta, and the distance traveled is s2x. What should come into your mind when you have these values? When you have initial velocity, final velocity, acceleration, and displacement? Exactly. The moment you have this, what thing should come into your mind? It should come into your mind that we can use v square minus u square is equal to 2ax. Whereas what is v square? The final velocity. What is the final velocity? Vc. So we have vc square. What is the initial velocity? It is initial condition ub, so we have the vb square. Now, I'm not taken here vx, vb and vc directly. Why? Because this equation represents the general motion, but motion along AC represents only the motion along the x-axis, since there is no vertical motion here. There is no vertical motion, so all the motion that takes place here will be with respect to the x-axis. So we'll have to replace v with vx and u with ux. However, Vx will now become Vc. Why? Because the only component of velocity here is Vc. So we have Vc square minus Ux, which is velocity B here, minus Vb square is equal to 2a ax. What is ax? Displacement along the x direction, which is 2x. So we have 2 into 2x into, 2 into displacement, my bad. Acceleration is ax, which is g sine theta. So we have 2 into g sine theta. Displacement is 2x, so we have 2x here. Therefore, we can write that vc square minus vb square is 2g sine theta. Vb is velocity at top of the body, which is 0. So vc square minus 0 square is equal to 4 into g into sine theta x, and therefore vc square is equal to 4g sine theta x. Are we done with the question? The question is not to find out the velocity, the question is to find out the coefficient of friction. Are we there yet? No, because there is no friction in this motion, right? Let me just make a note of that. There is no friction acting in this region, right? Now, if we come to the second portion, for the motion along BC, the plane is rough. My bad, it shouldn't be. Okay, so let us compare these two motions. So for motion along BC, we have AC is equal to x, AC equal to m, BC is equal to 2x, and BC is 2x. And when this B body reached C from B, the velocity at C we just found out to be 4g into sine theta x, right? Now we'll consider the next portion, which is motion along CA. So BC, the body has a velocity VC at 4g sine theta x. Now what we'll do is motion along CA, how the body here will start moving from VC and eventually it will come at VA, and it is given to us that this VA is equal to 0. So now we have a motion like this from BC to VA. Now if you consider motion along CA, VC is equal to 4g sine theta, VA is equal to 0, we know that. Now motion along CA, we also need to understand what are the various forces acting along this CA. When the body is sliding down, there's only one additional force here. Earlier we had mg and n. Now the overall direction is downwards. Since there is friction on the surface, the friction will oppose the relative motion, and relative motion would be opposed like this. So we have opposing relative motion for the friction of kinetic nature. Why is friction kinetic here? Because there is some relative motion. Now, if you draw the free body diagram of the block, we can replace this weight by resolving it into two components. One is the horizontal component and other is the vertical component, which means in the free body diagram you can replace this weight. So now you have four forces: N, Nd sine theta, Mg cos theta, and F kinetic. Now since there is no motion along the y-axis, we can say that sigma Fy is equal to 0. Therefore, forces acting upwards should be equal to forces acting downwards, and therefore N is equal to mg cos theta, because the only force acting upwards is normal reaction and the only force acting downwards is mg cos theta. Okay. Now, for the same block, if you consider motion along x-axis, there are two forces acting along the x-axis. One is mg sine theta downwards, and this kinetic friction acting upwards, or sliding downwards and sliding upwards. The overall movement is downwards. Therefore, when you take sigma f, you will have to assign sign for these frictions. Since mg sine theta and displacement are in the same direction, we will take mg sine theta to be positive. We'll take mg sine theta to be positive. And since friction is acting upwards, we'll take friction to be negative. So friction is equal to minus mu k into n. What is n? N we just found out to be mg cos theta. So we can replace n as mg cos theta. And therefore, if you divide this entire equation by m by m is 1, m by m is 1, m by m is 1, what you get is g sine theta minus mu k g cos theta is equal to ax. So what was the acceleration the previous half? Acceleration there was g sine theta when the slope was smooth. When there is some amount of friction, acceleration here got reduced further by an element g sine theta minus mu k times g cos theta. Okay. Now what we'll do is we'll consider the motion along CA with this acceleration. So if you consider that part, how do you approach it? For the motion along x-axis, acceleration is g sine theta minus mu k g cos theta. V square minus u square is 2as. V will be replaced by vx, u ux, and a will be ax and sx respectively. What is vx? Velocity in the final, which is va. What is ux? Velocity at which the motion started, at c. So the velocity is vc, and therefore ux square can be replaced by vc square. Now ax is g sine theta minus mu k g cos theta. Sx, wait a second. Sx here is x because we assumed AC to be x. So into x. Now VA square is 0. VC square we found out to be minus 4 minus VC square we found out to be minus 4g sine theta into x. So we substitute the value here. Ax is 2g sine theta minus mu kg cos theta. You can discard this x and x. So essentially what you get is, okay, wait a second. Okay, I just wanted to show you that VC square here is 4g sine theta into x, the previous one. Now let us go through the solution of this one. So if you solve it further, what we get is x by x is 1, right? If you divide this entire equation by x by x is 1. So we have 4g sine theta into 1 is equal to 2 into g sine theta minus, I multiplied this 2 inside the bracket. So 2g sine theta minus 2 mu g cos theta. If you divide this entire equation by 2g, 4g by 2g becomes 2, 2g by 2g is 1, 2g by 2g is 1. So we have minus 2 sine theta is equal to sine theta minus mu k cos theta. And if you transpose the sine theta to the LHS, what we have is minus 2 sine theta minus sine theta is equal to minus 3 sine theta, which is equal to, my bad, this should be minus mu k cos theta. And then if you divide this complete equation by negative 1, minus 3 by minus b become positive. Sine theta cos theta, sine theta by cos theta becomes 3 tan theta, and therefore 3 tan theta is equal to mu k, or otherwise mu k is equal to 3 tan theta. And if you compare this question with the given value here, it is given to us that the value of the coefficient of friction is given by mu is equal to k tan theta. Mu k is equal to 3 tan theta. What we is given the question is mu is equal to k tan theta. If you compare these two equations, mu tan theta, we analyze that the value of k is equal to 3. Now we will discuss this question. We have completed this question in solving using the laws of motion method. Now what we'll do is we'll solve this using the work energy theorem.